Welcome to the third video in this series on making our block breaker game in Godot using C#. Now, I've printed our design document to a PDF so that it's easy to reference in the future. And with our design document, it's going to be pretty easy to just kind of see what we need to do and where to start and what we have to do next. So for now, why don't we kind of start with this initialization stuff and getting our player moving the way we want, and maybe taking a look at some basic, stuff on getting this player to move the way we want it to. So in our world, like I said earlier, we didn't write this down, maybe we should, but the idea is going to be that the player is moving forward and dodging obstacles to the left or right, or by jumping over them. So let's make the player do that. The first thing we're going to do is you want to decide how do you want the player to interact with your character, our box in this case. Well, by default, in our default code, which I can pull up here, this is the code that, that Godot gives us. And if we look at this comment, it says, get the input direction and handle the movement declaration. As good practice, you should replace UI actions with custom gameplay actions. And well, what does that mean? Well, what that means is we can look in our editor, or I'm sorry, in our project settings, and then input map. And right now it's empty. And that's because we haven't defined anything yet. So if we see what are the default actions, we can see there's a whole bunch. There's UI accept, UI select, UI cancel, left, right, up, down. You can see that it's mapped to some buttons and even the joypad. And that's all cool. But why don't we define our own? So what are the actions that we need? Well, we need to be able to move left. We need to be able to move right. And we need to be able to jump. And that's it, right? That's all our player is going to be able to do for now, according to the design that we've put together. So that's all we need to do to define our actions. And when we're when the player is interacting, Godot is going to send off one of these things when the player presses the right button. Now, we haven't assigned any buttons yet, so let's add that now. Well, if we want our player to be able to use the keyboard, typically, in order to move left, you can press the left key. So let's do that. But then also, it's common to have WASD controls. So why don't we make A go left, as that's kind of standard now. So we'll scroll down and there's A. And then we also want the controls, or a controller to work. So let's go joypad buttons. Let's see, all the way at the top. So left action. So no, that's not what we want. That's the, if you look, it's like, oh, Xbox X. That's not what we want. What we want is the D-pad. So let's scroll down. D-pad, there we go, D-pad left. Okay, and then let's also let the player use the left joystick. So the joystick is actually an axis. So we use joystick axis 0, joystick left. Okay. So we're going to go through the same exercise for move right. So right. D. 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 Oh, you can also do it this way, I suppose. That way. So I just pressed my controller and controller right. Okay. Now jump, I'm going to just say is spacebar. Okay. Or the A button on an Xbox style controller. Whatever that is on PlayStation. It'll Godot handles it for all the different devices, so you don't need to worry about that. Okay, well, that's our input. So that's already taken care of, and now we don't really have to think about it again. We should go ahead and save just so that that is saved. Okay, now in our first video, we made this area playground. Let's go ahead and get rid of this ball. That's not really going to be part of our game. And since we're just going to be on a track that moves forward, let's take our ground and we're going to make this mesh instance really, really big. So we did this before, but we didn't talk about it a whole lot. So in 3D space, in Godot and in other engines, a 3D object or 3D node has a transform, and the transform defines where the object lives, its position, its rotation, and its scale. So the position is just literally on the XYZ grid. Where is it? So again, the red axis here is X, the blue axis here is Z, and the green axis is Y. So if we wanted to make this really, really high up in the air, we could go 10 and it would be like up there, or even 100. It would be way, way up. And if we wanted this to be like way out in front of the player, we could do like, or that, okay, so that's actually backwards, so -30. But what we want is we want this to be a track that kind of runs off into the distance that's really long. So let's make this like, let's do 500. Now its position is right here in the middle, and our player starts right there. So we can make a choice. We can either move our player back or we can move this object forward. Now, you have to note that since we are messing with the mesh instance position, this is relative to the actual parent node, the ground position. So like this node, this has its own transform. We don't want to mess with the scale on ground or in the collision shape. You'll get an error. Like let's just say if we were to try and mess with this and make it the same thing, what did we do, 500? Oh, that's gonna make it everything. So if we did 500 like that, it'll normally, yeah, there's that error. And it says a non-uniformly scaled collision shape will probably not function as expected, make it uniform. And wow, that's really big. So the way to change the collider shape before we do anything else, we want to make this collider shape match our mesh. Otherwise, you'll be like falling through the world and not knowing why. Then if we want to change this, we made the mesh 500, so we can put this, let's put it at -240, just so, -230. There we go. So now if we play this, now, once it's built, now we can run around in our world. Oh, so let's see. So we can use our arrow keys. What we haven't done yet is we haven't said, oh, hey, use those actions we just defined, like, you know, move left, move right. And since we're using the default character controller given to us by Godot, we just have to use the arrow keys. And we're really, really slow. And we can jump off and whatever. Okay, so the character controller that Godot has given us doesn't really match up with what we want our character to do. And it also doesn't feel all that great from the character, or from the, you know, player perspective. So let's pull this script back up. Oops, to go to our player, mess with the script. Okay. So let's take a look at the code. Now, again, I'm assuming you have some familiarity with programming, but we will walk through kind of what is actually going on in this code, because, of course, this is all stuff provided by Godot. So even if you know C# and are an expert, you probably won't know a decent amount of this syntax because, you know, this is like implemented by Godot. So let's just start from the top. So we can see that player, this script, extends character body 3D. So we know that we have access to character body 3D and everything that it extends. So that's physics body 3D and a few other things, node 3D and node. If we just take a look back over here, if we look at player, we can just see what we're extending. So character body 3D extends physics body, which extends collision object 3D, which extends node 3D, which extends node. So any of the member functions that these things have, we can call, or we can mess with the member properties that these things have. And this is a really big thing to keep in mind when you're working with an engine, is that in your inspector is showing you all the different properties of each of these things. Those can all, because this is an extension of character body 3D, in our code, we can mess with all of that stuff as well. So for example, if we, like right now, our player, if we look at our player, we look at the transform like we were talking about earlier, it starts at 0, 0, 0. But we could say public override void ready, which is just a default function. We can change our transform. Let's say we wanted to change our starting position just using code. So if we wanted to say start off the floor, up in the air, what we can do is first consider that position is part of transform. Position is a vector3 type object. Vector3, say start position equals new vector3. Then we can say, whoops. Yeah, then we can say start position dot y equals, let's say 5. Then we can just say position equals start position. Now, if we go over to our playground, we run this. So just by hitting run, Godot's going to automatically compile our C# code. And you can see we start in the air. Let's do that one more time just so we can see it. Cool. Okay, so now let's go through physics process and take a look at what Godot has provided us with. So vector3 velocity equals velocity. If is on floor. So this is some method that we're already given, which is nice to know. And this says it returns true if the body collided with the floor on the last call of character body 3D, move and slide. Okay, we're gonna have to keep that stuff in mind. Move and slide is on floor, character body 3D. So we already know we have a character body 3D, that's our player. We have a collider, and if it's on the floor, then it won't do this because it's if not is on floor. And this is doing, so if we're not on the floor, our current velocity, or this velocity that's going to be set later, we subtract gravity times float delta. Okay, cool. Then handle jump. Okay, so if input is action pressed, UI accept, and is on floor, then velocity equals jump velocity, which is a variable that was defined in our code already. Cool, so if we're on the floor and we hit jump, then we're going to add some jump velocity. Otherwise, we're going to fall according to gravity. Now, before we go too far, what I'm going to encourage you to do is, after you're done with this video, or just pause this video right now, and go look at some, conventional ways of doing jumps and implementing them. And in fact, if we just pull up our project, I'll maximize this. If we jump, you can see the jump is pretty floaty and not very high. The reason is most jumps in video games are implemented where at the peak of the jump, you actually accelerate gravity. So let's change this a little bit. So So, so this is good. If not is on floor. Well, what do we want? Well, we want if our character has reached the peak of the jump. What does that mean? Well, that means if velocity dot y is less than 0, then what we want to do is we want to do this except by some gravity multiplier. So let's up here, we'll say, let's see, I don't actually like making these public either. So const float grav multiplier equals 3f. Okay, so over here we're going to say grav multiplier times gravity. Else, we're just going to do that. Now, let's see how that changes things. All right. Now you can see when we're going up, we still sort of float up, but then when we come down, we have a pretty sharp drop. And that's the way most games are actually implemented. You're going to want to play with that a little bit to find what exactly the right multiplier is for the way you want your game to feel. We might do, instead of 3, we might do 2. But we're going to want something like 2 to 3, somewhere in that range probably. Let's just see what 2 does. All right. We still get a sharp drop, but not quite as much as normal. So you can play with that, see what you like. I also think our jump should be just a little bit higher. So let's go like 8. Oh, that's really high. Okay. Let's try 6. Now, we're doing a lot of switching back and forth between code and the inspector and rerunning our game, and that's kind of inconvenient. I'll show you a trick in just a second. Okay, so that's looking kind of good. Maybe we went just like 5.5, but let's stick with this for now. Okay, so while you're doing this, or just at any time really, what we can do is take this jump velocity and we can say export. We could also do this with our grav multiplier. Export. Let's take out constant. We're not expecting to change it, but we're not going to be changing it in the code. But since we're going to be changing it in our inspector now. So recall that I said any of our properties in the inspector we can mess with in the code. We can also say export to say, I want this variable or this thing to be visible in the inspector. So we've exported it and we're telling Godot, I want you to show this in the inspector. Now, if we look, we're not seeing it. That's because for C# we need to rebuild the code first. Okay, so now we can see jump velocity and grav multiplier. So now let's run our game. All right, so that's what we were just doing. So let's change this to 10. Then if we go over here, now you can see we've got this massive jump. Let's change it back to maybe 5.5. Now we're almost exactly back to where we started with the 4.5. And let's try what happens if we change it to a 3. It's much sharper. And just for fun, just to see what happens, let's see what happens if we do 10. Oops. Now it's really sharp. So this is a nice way when you're testing things out. Let's do 2.5 and let's do 6. So when you're testing things out and just kind of getting a feel for how do I want my character to control, what do I want it to feel like, before you ever start actually designing your game, it's good to have a character that you really enjoy controlling, that feels good. I'm also noticing, man, we're really, really slow to move side to side, and that's not cool. So we're going to do that next. But I'm kind of liking this for the jump. That's looking pretty good. Okay, so let's do this next. Let's go ahead and do export. Let's do, I don't know, 10. Okay, so now since we did all that, again, we have to rebuild. Now we can run our game. All right, I'm kind of liking that more. That's a good speed. Okay. Now, notice that we've changed this in the inspector, but it hasn't changed in the code. So we can make it align so that it's just aligned, just so that we don't need to worry about changing it over here. If we come over here and rebuild it, Godot sets these different values to default values, and if you change them, you can always revert it back. So whatever's in the code, if this is different, then you can always just revert it back. This isn't going to push these values back into your code itself. So if you want once you arrive at something that you really, really like, I like to set it in the code just so I don't forget and like go change that at some point and say, why isn't this the way I wanted it to be? Okay. Now the other thing is we went and we defined these different movement things that we wanted, and we haven't used that yet. Right now it's using UI accept, and it says we should replace these with default actions. And there's a few different things that are going on that we don't really want. So first, we're just going to say jump. Now let's just double check and make sure that works. And yep, that does. Then down here, this is a for like a 3D sort of open world type game where you can go forward, back, left, right. But what we had said earlier is that for this game, the player is going to go forward kind of out of their control no matter what. The game's just going to drive the character forward. But the character is going to be able to go left and right. The player is going to be able to go left and right. So what we're going to do is we're going to let's just take all of this out. So, all right, we're going to say push character forward. So velocity dot z equals, now let's say negative speed. And for 10, I think we're going to want the character to go faster. So let's do export float forward speed equals, let's say 30f. And let's say side speed equals 10f. So let's do forward speed. Okay, so now we're pushing the player forward at a constant forward speed. Now, if the player moves to the left, we're going to want to handle that. So if input dot is action pressed, we have just pressed or pressed. So let's say is action pressed, because we just want it to keep going, move left. Then what do? We say velocity.x equals negative side speed, because we want to move to the left and the negative x-axis is to the left. Else if, input dot is action pressed move right, then we're going to do the other way. Velocity.x equals side speed. else if velocity.x greater than 0. What we're going to do here, rather than just stop instantaneously if you're not moving to the left or moving to the right, I'm going to have the player sort of slowly slow down, kind of like there's friction. So velocity.x minus equals, so yeah, we're greater than 0, so we need to subtract speed. Side speed times, we'll say times 2 to make it go fast, and then float delta, else if velocity dot x less than 0. Then we have to add it, velocity dot x plus equals side speed times 2 times float delta. All right, so let's try this. I'm going to test it both with the arrow keys and with W and D. Yeah, that looks pretty good. Now, as it is, yeah, I think we like having the instantaneous change if you're already moving. That's going to give the player a little more control, and that feels pretty good. So we have our player. You can kind of play around with those numbers. You can make these variables that are exported if you want, just to kind of play around with your friction. But I think that's we're in pretty good shape with the player. So let's leave that for now. And let's go to our playground and let's make a goal. So we're going to add node 3D. We're going to call this goal. And we're going to put it way at the end. And if you hit F, you can focus on whatever it is you're working on. So this, we're not going to actually give it a collider. Or I'm sorry, we're going to give it a collider. We need to have a shape. But we're not actually going to do anything if you run into it. And we're going to learn about a different type of collider that is in Godot. So we're just going to add child node. And we're going to call this an area 3D. So an area 3D, this is just used for if you want to detect that you are somewhere, that you are in a certain place, but you don't want the physics engine to have you run into it. This is like you made it here. So we're going to give this, we see this error and it says this node has no shape, so it can't collide or interact with other objects. So let's give it a collision shape 3D. And we need, again, to give it a shape. So we're going to give it a box shape. And we're going to raise that out of the ground. And then we're going to pull it over the whole width. And then just in case the player jumps over it, we're going to raise it up. And then I'm going to leave it right about there. Now, so it's okay. So now if we run our game, we're not going to like run into this or anything. This is literally just to detect the fact that our player made it there. So let's go all the way to the end and just kind of see what happens. You can see it's right up there, and we're racing right towards it. And what happens when we get there? Nothing yet. What actually happens, what we're going to do, why don't we put it right in our player script? We're going to have a method that is called when that area is entered. So we're going to say public void on area entered. And I think we have to do body node, node body. Okay, so what this is saying is this is some function that is going to be called when we enter that area. Why don't we actually call it on goal area entered? Now in Godot, Godot provides what are called signals. So a signal is when this area is entered, it will emit a signal. And the signal will actually call that function that we just defined. So let's go up here, and it says on area body entered. So on body entered, and it needs an argument of body node 3D. So let's go with that one. What we're going to do is just double click it and then connect signal to a method. So what we need is we need to look in our script. So we're going to say pick there. See. Oh, I know. Yet again, okay, we have to build this first. That's the issue. All right, now on goal area entered. Enter, then connect. Okay, so now what we're going to do for now, all we're going to do is output a message in our console, which we haven't done yet, but this is our console. All we're going to do is say, we're going to say GD, which is Godot. And this is just a bunch of member methods that are provided by Godot that you can use. And print U1. And that's all. So let's just test this out. Run it. And this is the easiest level in the world. We just have to sit here. Let's actually minimize it so we can see what happens. So here we go. We're racing right for the goal. And you won. Pops up right there. So that's what happened when our character body went through this area. Now you might be saying, well, what's with this argument? What's this? This is when a body of some, or when a node having some body enters that area, this is a reference to that node. So what we could do is say if, that's not, if body.name equals player, we can go like this. This would be the more kind of formal way of doing it. And this would be more for if you have like a bunch of other things in your world, like your player character and enemies, or maybe if you were making a soccer game and you wanted to detect if the ball went into the goal, then you could use an area and say if body.name equals ball, then, you know, add a score and do whatever. Otherwise, just ignore it, or maybe you call a penalty on the player who went into the goal, something like that. So we can do it this way because we know that this is the only body that's going to get in. Or we might have some issue if we had a collider, if we had our area like overlapping the body of the world in some way or something. So we can do it this way just to say the only thing we care about is if the player enters this goal. We're going to delete this for now. Well, we can just leave it in for now. We'll take it out later. So let's say, oops, to do remove this later once implemented. Okay, so now for one more thing we can do, why don't we make some basic obstacles? Okay, so let's make a basic obstacle. So we're just going to add a new scene, other node, and we're just going to give it a static body 3D. And a static body 3D can have as many shapes in it as we want. We're going to say this is a far side cutout obstacle. And we need to give it a shape. First, what I'm going to do is give it its mesh. So I'm going to say mesh instance 3D. And this is going to be a box shape. And we're going to make it 5 width. And it'll say 2.5. Then we're going to say this is the left side mesh shape. Give it another one. Say right side. This 20. Put it right at 20. Okay. Now we can add our colliders. Collision shape. Say this is the left side collision shape. Give it a box shape. We'll make it align by putting its position at 2.5 and then drag it out. And then for this one, the same thing. We'll say, collision shape. We're going to say right side collision shape. And at 20. Focus on it. Need to get shape. There we go. Oh, and the other thing is I want these to be tall so that you can't just jump over them. So, so let's say that the Y is 20, which we need to put our starting position at 10. And then same thing with the right side. 10 and 20. And this start at 10. Drag it up. Drag. Okay, so there's our basic obstacle. We'll say we're going to put this in a new folder, obstacles, side cutout. And there we go. So now in our playground, we say obstacles, far side cutout. To playground, and why don't we actually make a node 3D, and we'll just say that this is obstacles just to keep our inspector organized. Nest that in there. Now you can see it's sort of off center, so we're going to have to actually put it at -15 to get it to line up, and then we can just kind of position it where we want. So let's put it maybe right about there. Let's make 3 more of them, or 2 more of them. So we're going to just hit Control D, and we'll get another one. And for this one, let's spin it around. So 180. And we're going to have to say 0. Oh, 15. Let's move both of these back just a little bit, just so that the player knows, hey, stuff's starting to come at you. And let's duplicate this one more time. Have the player sort of go back and forth. And it'll be a pretty easy intro to the game. Play. All right. So now we've kind of got the semblance of an actual game. Okay, so now that we have this stuff, I'm kind of seeing that um, our camera is right on our player, like centered on the player. And I actually want the camera to be sort of have the player, um, let's see, sort of in the bottom. That, there we go. Okay. Oh, we've got it like snapping to the grid, I think. Let's see what that looks like. Just see if we look at this scene. Let's go transform. Or that way too high. Oh, it's actually not bad, but we are sort of getting. Why don't we do this? We'll go 3. We'll just rotate it up just a bit. And we can actually just preview right there. 20. There. All right. Now we've got the player kind of in that rule of thirds position. Let's just run this one more time and make sure it looks good. All right, yeah, I'm liking that a lot better. Okay, so we don't have any sort of death yet, but that's okay. We've got our first scene, our first area, and this is good. So why don't we stop there for now, and on your own, create a few more scenes of different obstacles and then a few other combinations of obstacles, and you can create a few levels. Uh, you could even make a moving obstacle if you want, like something that spins around that you have to jump over. So I'll leave that as an exercise to you. Don't worry about transitioning between levels yet. We'll get into that next time. So for now, thanks for watching and have a good one.